Question number 11. A company opens an account with an initial balance of $36,100. The account earns interest, okay, and no additional deposits or withdrawals are made. The account balance is given by the exponential function, okay, where AT is the account balance in dollars, T years after the account is opened. The account balance after 13 years is this much. Which equation could define A? See, before solving this question, I just need to explain the concept of exponential function in a little bit more detail. So let's move to that part. I'll create two situations, right? Where the growth is happening, as in this case, money is growing. And the second case, where decay is happening. So let's see the growth first. Suppose you have $1,000 in your bank account and bank agrees to give you 10%, mind every word, 10% on accumulated amount. That means it is not fixed. Every month, okay, 10% per month is very high, but that's okay. Just not relate to the situation, right? Like it's not possible. Let's try to understand the concept behind it. So 10%, okay, let's say here, on accumulated amount. So this is the initial amount. It's the beginning amount. Now after 1 year, 10% will be added to it. So what is 10% of 1,000? 10% of 1,000 is 100. So the bank will give you $100 as interest, and after 1 year you will have 1,100. Now this 100 is not fixed, right? If it is fixed that every month you are going to get $100, then it is a linear situation. But here 10% will be on the accumulated amount. So it's for the first year, right? For the first year, it's the initial amount. Now, in the second year, 10% will be of 1,100. Perfect, which is 110. So we will add 110 into it, or the bank will give you this interest, and now you will have this much of amount. See, the interest has increased because gradually the amount is increasing, and so is the interest. Now this is exponential growth. If I create a formula for this, till now you know formula is y is equal to apx. But let's break it a little bit so that we can understand the value of b better. Actually, its amount after some time, right, after t years, is initial amount times 1 plus rate percent, and it's for how many years. That is the actual equation. Now here initial amount is 1,000 and it's 1 plus 10%. This is t is time, so it's amount after t years. So we will just keep on putting the value of t and calculate how much the amount will be in our account. Now the next point is, here I am adding something to 1. It may be a very small value, but because I am adding it, it will be greater than 1. That is the most important point here. So it's 1,000 and 1.1 raised to power time. That is the situation. So we can analyze it a little bit more, that 1,000 is the initial amount. 1.1, that means amount is increasing. Now let's see another situation. Suppose you have a radioactive material and it decays 10% every year. I'm taking same percentage, 10. So let's say initially it's 100 milligram, let's say, right? It's initial, in the beginning when we have started the experiment. Now in the first year that will be 10% of 1000, right, which is 100. So after 1 year it will be 900 milligrams. After first year it will be 900 milligrams. Now for the second year, right, it will be 10% of 900, which is 90. So it will decrease 90 milligram, and so it's 810 milligram, right? So see, every year the amount is changing. That type of growth is, or decay is, exponential decay. And for this, formula is radioactive, after radioactive element remained after t years is initially how much it was, right? Initially how much it was, and it's 1 minus rate percent after t years. Now if I say it's 10%, 1 minus 10% is 0.1 raised to the power t. I am subtracting something from 1, whatever small the number is, but definitely it will be less than 1. So here it is initial amount, right? And this number is less than 1. Now that is the most important point here. If it is a decay or a decrease, this number will be less than 1. Or if it is increase, this number will be greater than 1. Otherwise, both the equations RT or AT, in the first case it's AT, in the second case it's RT, it's y is equal to A, B, X, where A is the initial amount, Y is the final thing, whatever is that, B is the rate of change after this much time. Now if this B is greater than 1, that means growth is happening because we are adding something to 1. And if this B is less than 1, that means decay is happening. Now this concept will make us understand the question better. Let's go back to the question. A company opens an account with an initial balance of $36,100. So if I say y is equal to ABX, so 36,100 is the initial amount. The account earns interest and no additional deposits. That means there is no extra money. You have to calculate only this much. After t years, the amount is this much. See, amount is increasing. So here, this value has to be greater than 1. Here it is time, and that is amount of t, which is given here. But if I see the options, this part is not used in my answers list. That's okay. That's totally fine. Question is demanding that you know where to place the initial value and how will you figure out that the number B will be less than 1 or greater than 1. So initial amount is 36,100. This is the option. It's not the initial amount, cancel it. It's not the initial amount, cancel it. Now if I see A and D, this decimal 0.5 is less than 1. That means here decrease is happening. Decrease in the money is happening, but our money is increasing because we are taking the interest. So that means A is the right option. I hope if you will go through the whole concept one more time, exponential functions will make much more sense to you. So keep revising and let's meet in the next question with the next question in the next video.